So in this concept, we're going to talk about scientific notation. And scientific notation is a way to write very large and very small numbers in a shorter form. A form of a, which is some constant, times 10 to some power, okay, some exponent, where a is has to be between 1 and 10, okay, and n is an integer. The exponent has to be an integer, and a has to be between 1 and 10. So a is called the coefficient, and 10 to the n is called the base and exponent. Okay, the exponent in scientific notation has to be equal to the number of times you have to move the decimal point to get to the first non-zero digit in the original number. So, for example, if you had something like, 7,500, right? This is essentially equivalent to 7,500.0, right? So this is the point. In a whole number, the point is written at the end of the actual number. Okay, so 7,500.0. And now, if we want to write this in scientific notation, you would say, you would move the point, the dot, 1, 2, 3, right? Because again, the number has to be, you couldn't have 75, right? You have to have 7.5 because it needs to be between 1 and 10. The a value has to be between 1 and 10. So 7.5 times 10 to the how many times you've moved the decimal point, which in this case is 1, 2, 3. So 10 to the third, right? So 7,500 could be written as 7.5 times 10 to the third. This was a very quick example, and we'll go through more examples very soon. But let's just reconfirm the two cases of the different values that the exponent could take, right? Whether it's going to be negative or positive. The exponent being the n value that's up here, right? So in the case where you move the decimal point from the right to the left, so opposite the number line, opposite the positive direction in the number line, okay, then the exponent is positive, right? So think of a number line, right? So 0, and you typically go positive to the right, and you typically go negative to the left. Well, this way, in here in this case, if you move from the right to the left, then your exponent becomes positive. Okay, when you're writing out the number in scientific notation. If you move the decimal point from the left to the right, so going to the right, then your exponent is negative. Okay, and we'll see why that is, because in one case you're writing a bigger number in scientific notation, a very big number. In the other case, you're writing a very, very small number. So each of them, again, is determined by the sign of the exponent. Let's look at some quick examples. So write the following numbers in scientific notation. So 5,480,000. In this case, it's a very large number, and in this case, this is equivalent to 5,480,000.0, right? So this is the point. This is the decimal point. In this case, we want to move it towards the left. So 1, 2, 3, 4, 5, 6. So I've just moved it 6 spaces from the right to the left, and my number becomes 5.48. Okay. Why did I stop the dot here, the point here, as opposed to, after the 4 or after the 8? Again, because my number, my coefficient, right, which is a, needs to be between 1 and 10. Okay? It has to be between 1 and 10. So I can't have 54.8, right? I can't have 548, etc. That's not scientific notation. Okay, so the coefficient has to be between 1 and 10. So now I have 5.48 times 10 to the 6th. Okay, so again, we move the decimal point from the right to the left to the first non-zero digit, so 5.48. And then you can drop all these zeros, right, because they're just insignificant at this point. Okay, and then we've written the exponent with the 10, and this, so 5,480,000 in scientific notation is 5.48 times 10 to the 6. 0.00003. So that's 4 zeros and then a 3 after the decimal point. So again, same process, but we're going in the opposite direction because this is a very small number and we're trying to write it in scientific notation. In this case, you would move the decimal point from the left towards the right. So 1, 2, 3, 4, 5, right? Because I can't have 0.3 times something, right? It has to be between 1 and 10. Again, my coefficient has to be between 1 and 10. So the point has to be after the 3 such that the coefficient is actually between 1 and 10. Again, so 1, 2, 3, 4, 5 spaces, right? So 3.0, right, times 10 to the 5th. And again, whatever zeros there were after the 3, we could just drop them, or you could just keep it in this standard form, 3.0, 10 times 10 to the 5th, okay? So 0.00003 in scientific notation is 3 times 10 to the minus 5. Now we have some quick exercises. Please pause the video, work on these, and come back for the solutions. Okay, so let's write these in scientific notation. So 443, so this is 430,000, right? So 430,000. So 0.0, right? So we need, where would the point end up if we moved it to write this in scientific notation? Well, it should end up here, right? It should be 4.3 and then some number of motions that the point would have made. In this case, the point will have to move 1, 2, 3, 4, 5. So the point moved 5 positions or 5 spaces, and my coefficient is 4.3 times 10 to the 5th. 70 million. Okay, 70 and then 6 zeros after this first zero. So 70 million again. So the point. Well, let's actually write it more spaced out so you could see me moving the decimal point. So 70 and then 1, 2, 3 and then 1, 2, 3. 0.0. Okay. So the decimal point here is going to move 1, 2, 3, 4, 5, 6, 7. So 7.0 times 10 to the 7th. Because we're moving from the right to the left. 0.12. In this case, the decimal point is moving from the left to the right by 1 position. Okay, so 1.2 times 10 to the 1, the first power, which is just 1.2 times, 10. Same. You could write it either way. You could keep the 1 or you could remove the 1. In this case, they're both the same. 0.00000015. So there's 6 zeros. In which case, the decimal point would have to move 6, 7 positions. Okay, so you're going to have 1, 2, 3, 4, 5, 6, and then 7, because again, my coefficient needs to be between 1 and 10, so I can't have a coefficient of 0.15. No, it has to be 1.5 times 10 to the, well, there was 7 positions, but remember, they went from left to right, so it's going to be negative 7. Okay, so the exponent is going to be negative because there were 7 positions. 2500. So this is the same as 2500.0. So 1, 2, 3. Right? So 2.5 times 10 to the third power, again, and this is positive 3, not negative 3, because we moved from the right to the left. Okay, this is it for this concept. See you in the next video.